Okay, so this paper is about why RAG systems break at scale and how Chameleon fixes it. Now, if you're running RAG in production, you've probably noticed something odd. Your model might be small, your prompts might be reasonable, and yet latency spikes, costs balloon, and throughput plateaus far earlier than expected. This paper argues the real bottleneck in modern RAG systems isn't the language model at all. It's the architecture we use to serve retrieval and generation together. First, some prior context. At a high level, Retrieval-Augmented Language Models, or RAG, combine two very different components. One is a language model, which is compute heavy and thrives on GPUs. The other is vector search, which is memory heavy and dominated by data movement. Early systems treated these as one combined workload. Typically, CPUs handled vector search, GPUs handled inference, everything lived in the same server. This worked for demos, but at scale, cracks appeared. Vector search started dominating latency. CPUs couldn't scan massive compressed vector datasets effectively. And GPUs, despite their power, turned out to be surprisingly inefficient for large-scale vector search due to memory limits and data transfer overhead. In short, retrieval and generation stress hardware in fundamentally different ways, and we've been forcing them to share the same resources. The central idea of this paper is straightforward but powerful. If retrieval and generation are different workloads, they should run on different hardware, and they should scale independently. The authors propose Chameleon, a system built on two principles: hardware heterogeneity and disaggregation. Here's how it works. Language model inference runs on GPUs, exactly where it excels, whereas vector search runs on specialized near-memory accelerators implemented here using FPGAs placed next to large pools of DRAM. These components are not bundled into a single server. They are disaggregated across a network and coordinated by a lightweight CPU control plane. This allows the system to scale retrieval capacity without over-provisioning GPUs or vice versa. This isn't just a hardware optimization. By moving vector search closer to memory and offloading it from CPUs and GPUs, Chameleon dramatically reduces retrieval latency and energy consumption. In fact, in evaluations, the system achieves up to 2.16 times lower end-to-end latency, up to 3.18 times higher throughput compared to traditional CPU-GPU architectures. More importantly, the optimal balance between retrieval accelerators and inference accelerators varies wildly depending on the rack configuration. A fixed monolithic setup simply can't adapt to that reality. For enterprise teams, the implications are architectural. First, cost efficiency. RAG systems often pay GPU prices for retrieval workloads that GPUs are bad at. Chameleon shows how to avoid that mismatch. Second, predictable performance. Disaggregation allows bottlenecks to be addressed directly instead of masked with more hardware. And third is future-proofing. As models, databases, and retrieval technologies evolve, a modular system can adapt without full redesign. This is the difference between a feature prototype and production-grade AI infrastructure. If there's one takeaway from this paper, it's that RAG performance is a system problem. Check out the paper in the description below, and thanks for watching.